In this demo, I'm going to show you this dApp built with Filecoin Pin. Filecoin Pin is a brand new developer toolkit offered by Filecoin onchain Cloud. It lets you keep using your familiar IPFS tools and workflows with a major upgrade. Now your data can be stored and persisted by Filecoin's decentralized verifiable storage layer, powered by a global network of storage providers, all in one place. This makes you no longer have to rely on third-party vendors to keep your IPFS data available. Plus, your storage service is fully verifiable and auditable thanks to the on-chain cryptographic storage proofs and built-in payment on Filecoin. No central vendors or credit cards required anymore. So without further ado, let's jump in and see how it works in action. Okay, so here's my application that I just cloned and forked from the Filecoin Pin website demo over here, and I'm running it in my local host. As you can see, as soon as we launch the application, it connects us to the Filecoin network automatically and starting to initialize a storage service. The other thing to call out here is that by cloning the demo, we receive a session key that's authorized by a funded Filecoin Pay account. It allows us to use and pay for the Filecoin services directly in the app. Okay, now that the service seems to be initialized successfully, let's start uploading some data. So I have a quick cat video that I would love to store. Let's upload that. Okay, so as soon as we upload the data, the browser will create a IPFS car file for the file that we just uploaded and starting to uploading it to a Filecoin storage provider. Once a Filecoin storage provider receives the data, it will announce the IPFS CID to IPNI, and also they will submit a transaction to the Filecoin network to confirm that they received the data and they are storing the data. So this transaction is going to take about 30 to 60 seconds to be fully landed. You can click this link to check the status of that. But while we are waiting for it, as you probably have noticed, that the data is already available and we can try to download it from IPFS. So here you go. That's my very quick cat video that I just stored on IPFS and Filecoin. So over here, as you can see, the data is downloaded from the IPFS network. So behind the scenes, as I mentioned earlier, that the IPFS nodes will look up the CID from the IPNI, and the IPNI will discover that the Filecoin storage provider that we just uploaded data to has the data, and it will allow the IPFS node to download the data directly from the Filecoin SP. And here's my video I just showed you. Okay, let's go back over here. It seems like that our transaction on the Filecoin also landed, as you can see here. So quickly, let's look at the logs. Yeah. So from the logs, you can see that the storage provider submitted a transaction on Filecoin to confirm that the piece has been added and they're storing it. Okay, so once the transaction is landed on Filecoin, we have more on-chain information about the storage for this file. So let's take a look. So here's our piece that we just stored on Filecoin. As you can see, we are not the only one that's storing this data. Apparently, there are two providers that has this video, and they are in two different data sets. One is stored on October 13th, and the other one is just uploaded by us. Let's also take a look at the provider that we just stored our data with. So here is a detail page for the providers. So they joined the test network on September 4th, and since then they have been storing over 2,000 pieces across like 100 data set. And I believe this is the latest data set that we uploaded our data to. Let's take a look. Yes, EMQ. Yes, that's our data. Cool. So let's quickly see all the on-chain activities for your storage service here. So when we first launched the network, if you remember that we were initializing the storage service on the Filecoin network, and by the storage provider is actually the one sending a create dataset message to the Filecoin chain to indicate that they are ready for users' data. And then when we upload the data, the storage provider will send a message to the chain to indicate they are adding the new piece to the services to the data set they just created. And then a proving period is assigned to this data set. Which requires the storage provider to regularly proving to the Filecoin network they are still storing the data. To give you a better idea, let's take a look at an older data set. How about this one that's onboarded on September the 5th? Let's filter for the proof possession message. And this is the transaction the storage provider sends to Filecoin to verify the storage service they're providing. And as you can see on the testnet, every 30 minutes, they're sending a message to respond to the storage challenge so that you do not have to blindly trust the service provider is actually storing your data, but you can actually rely on the Filecoin network to validate that for you. But yeah, that's it. This is a very simple application with a drag and drop interface to persist your IPFS data on Filecoin. And as you can see, we're using mostly the IPFS tools and the workflow that you are already familiar with. And we are just using the Filecoin decentralized storage network in the backend as the persistent layer for your data storage seamlessly. But by using Filecoin, it gives you more transparency over the storage service that you are receiving and allows you to validate and audit the service on the Filecoin chain. If you'd like to learn more about Filecoin Pin, which powers this app, you can check out all the documentation, and that's linked over here. And now you can clone this demo, try it out for yourself, and hopefully you can expand this demo and build more interesting and powerful application and product that uses Filecoin storage.